Limit Laws Part 5. We're going to continue looking at indeterminate limits and how to deal with them by doing more work. The work we're going to look at in this video is factoring, multiplying by the conjugate, multiplying by the least common multiple, and combining rational expressions. Here we have the limit as x approaches -3 of 1 over 3 plus 1 over x all over x plus 3. And already this is too many fractions. But let's try direct substitution first. So we'll directly substitute -3 in for x, since that is what our function is approaching. So we have 1/3 plus 1 over -3, all over -3 plus 3, and that was our direct substitution. And now we'll simplify. 1/3 plus -1/3 is 0, and -3 plus 3 is also 0. So we have 0 over 0, which is indeterminate. Which means we have to do more work. Now, I am one of those people that, because apparently there are types of people that have preferences about these things, but I'm one of those people that prefers fractions over decimals. But even so, I don't particularly love when there are fractions inside of my fractions. So we're going to try to simplify this rational expression a bit. So when you have fractions inside your fractions, it can be helpful to multiply by the least common multiple of the denominators, or sometimes called the least common denominator. So I have the limit as x approaches -3 of 1/3 plus 1 over x all over x plus 3. And I'm going to multiply by the least common multiple of 3 and x, which is 3x. For this problem, you could also try combining rational expressions and combine these two fractions here, if you felt like it. But in this case, multiplying by the least common multiple is going to be a little easier. So let's do that. So we have the limit as x approaches -3 of, well, let's be careful here. We want to distribute this 3x to each of these terms. So we end up with 3x divided by 3 plus 3x divided by x all over. I'm going to keep my denominator factored because usually that makes my life a little easier later on. Now let's simplify our numerator. Our 3's will divide out, and our x's will divide out, since they are common factors. So now we have the limit as x approaches -3 of x over 1, which is just x, plus 3 over 1, which is just 3. So we have x plus 3 in our numerator, over 3x times the quantity x plus 3. And now I see that I have a common factor of x plus 3 in my numerator and denominator, so they will divide out. So this x plus 3 will divide out to just a 1, and this x plus 3 will also divide out, but I have that 3x there. So this is equal to the limit as x approaches -3 of 1 over 3x. And I'm going to write that a little smaller to save room. I was just used to writing much larger fractions. Okay. And now I can use direct substitution. So I have 1 over 3 times -3, which is equal to -1/9. And that's how you can multiply by the least common multiple. In order to help you find the limit when you normally end up with an indeterminate form. Now we have the limit as t approaches 0 of 6 over t minus 6 over t squared plus t. The first thing we'll try out is direct substitution. So we have 6 over 0 minus 6 over 0 squared plus 0. And that gives us 6 over 0 minus 6 over 0, which is just a mess. 0 is not in the domain of this function, so we will have to do more work. Direct substitution won't help us. So when I look at this, I go, wait a second, I have two rational expressions. I should combine those. And in order to combine them, I'll need to have a common denominator. So it's helpful to first factor as much as we possibly can. So we have the limit as t approaches 0 of, well, 6 over t. Can't factor my numerator or denominator any more than that. But for my second rational expression, I can factor that t squared plus t. In fact, I can factor a t out of the t squared plus t. So I have t times the quantity t plus 1. And now I can combine these rational expressions. So when I look at these, I see that they both have a t in the denominator. But my first rational expression, my t, is missing a t plus 1. So I'm going to multiply that by t plus 1 over t plus 1. So I have the limit as t approaches 0 of 6 over t times t plus 1 over t plus 1. Because t plus 1 over t plus 1 is equivalent to 1, so I haven't actually changed the value of anything here. And I will keep this 6 over t plus 1, over t times t plus 1. What is happening? I'll need to remember to distribute this 6 as I do this, and I will end up with the limit as t approaches 0 of, well, this numerator will be 6t plus 6, so I have 6t plus 6, and then I have this minus 6, all over my common denominator, which is t times t plus 1. And now I can see quite quickly that this plus 6 minus 6 will cancel out. So I have the limit as t approaches 0 of 6t, where's my t, over t times the quantity t plus 1. And now I have a common factor of t between my numerator and denominator, so these t's will now divide out. So I have the limit as t approaches 0 of 6 over t plus 1, which looks much nicer, so now I will do direct substitution. Substituting 0 in for t, so I have 6 over 0 plus 1, which gives me 6 over 1, which is just 6. And that is the limit as t approaches 0 for that function. Ah, look at this wonderful mess. We want to evaluate the limit as x approaches 25 of 5 minus the square root of x, all over 25x minus x squared. First, we'll try direct substitution. So we have 5 minus the square root of 25 over 25 times 25 minus 25 squared. So that's equal to 5 minus the square root of 5, which is 5 minus 5. So 0 over, well, 25 times 25 is something, but that something is the same as 25 squared. So that will also be 0. So direct substitution didn't help us here. We ended up with an indeterminate form. Which means we must do more work. When I look at this, I see issues in my numerator and issues in my denominator. In my numerator, I'm seeing the square root of x being a problem, but I see that I have this something minus something, so I might be able to multiply by a conjugate here. In my denominator, I see something that can be factored. So I'm probably going to have to factor and multiply by the conjugate in order to evaluate this limit. So let's start with factoring. So we have the limit as x approaches 25 of, well, that 5 minus square root of x, that can't really be factored. So we have 5 minus the square root of x over, well, that denominator can be. I can factor out an x. So I have x times 25 minus x. Nice. Now that I've factored, I'll multiply by the conjugate. So I have this 5 minus x in my numerator. So I will multiply by the conjugate, which will be 5 plus the square root of x. And so that I'm not changing anything, I best also multiply the denominator by 5 plus the square root of x. So this will be equal to the limit as x approaches 25 of, well, let's use that difference of squares here, because these are a difference of squares. 5 squared is 25, minus the square root of x squared is x, so I have 25 minus x, over x times 25 minus x times 5 plus the square root of x. Make sure you don't lose that 5 plus the square root of x. That is a common mistake that I will see. Now, I have a common factor between my numerator and my denominator. My numerator has this 25 minus x, and my denominator also has 25 minus x as a factor. So they will divide out. And I'm left with 1 in the numerator. So this is equal to the limit as x approaches 25 of, I'll write my denominator first so that this fraction is a little more balanced. So I'm left with an x times 5 plus the square root of x and a 1. And now, I think I can probably use direct substitution. So this will be equal to 1 over 25 times 5 plus the square root of 25. So that is 1 over 25 times 10, which is 1 over 250. And that is my limit. And how you use both factoring and multiplying by the conjugate to help you evaluate a limit that originally gave you an indeterminate form.